Hi, my name is Pratika, and I'm the founder of Cognition. Modern GPUs deliver enormous theoretical throughput, but real LLM services rarely reach those peaks without smart engineering. In practice, inference pipelines often achieve far less than those peaks, leaving GPUs underutilized and costs unnecessarily high. For example, studies show persistent gaps between theoretical peak and actual throughput in LLM serving, and one industry analysis warns that without batching and scaling GPUs, they sit idle waiting for requests, which wastes money. In short, GPUs commonly run at only 40-60% utilization, effectively doubling or more the cost of a useful token. Large language model inference involves two very different phases that often waste hardware. First is the prefill phase, which processes the entire prompt in parallel using matrix multiplication, which is compute bound. Second is the decode phase, which generates tokens one by one and repeatedly reads from a growing key value cache, which is memory bound. Because decoding is sequential and memory heavy, GPU cores can idle wait for data, limiting throughput. In fact, one analysis notes that LLM inference is memory I/O bound, not compute bound. It takes longer to load 1 MB of data into the GPU than it is to compute on it. Likewise, Red Hat points out that the basic runtimes struggle with inefficient GPU memory usage and slow token generation, leading to idle GPUs. To address these challenges, Cognition applies a full-stack dynamic orchestration layer that implements every major efficiency trick in practice. What does this mean? Smart request routing. Queries are sent to the cheapest available GPU clusters. We treat each cluster as a Kubernetes agent and route each inference request to whichever server meets the latency target at the lowest cost. This real-time cost-aware routing uses factors like spot pricing, GPU availability, and request size to minimize spend. GPU scheduling and multi-cluster orchestration. The system continuously monitors queue lengths and GPU utilization across all clusters, balancing load to keep nodes busy. KB cache reuse. Many applications see repeated or similar prompts. Instead of recomputing them from scratch, Cognition shares memory of recent outputs. If two queries are identical or have highly similar prefixes, the decoded tokens and their KV stakes are reused. This semantic caching avoids redundant work and can reduce costs up to 90%. Cost-aware model selection. Every request is analyzed for quality and latency. If a lightweight model will suffice, we use it instead of using a 70 billion parameter model, greatly cutting compute costs. Then we have predictive in-flight batching. Orchestrator groups compatible requests, similar length token budget into batches per tailored GPU. It also adapts batch sizes on the fly based on the current queue dynamics and latency targets. For example, a static batch met with 8 requests before inference, but in-flight batching injects requests 1 token at a time. The result is kept GPU pipelines with no gaps. Each of these features is implemented in real time. Combining them, Cognition extracts dramatically more tokens per GPU second. By reusing cache and routing smartly, Cognition drives throughput towards where the industry is headed while keeping costs low.